The issue of battery waste is becoming increasingly urgent as the demand for batteries, especially lithium-ion batteries used in electric vehicles and portable electronics, continues to rise. These batteries contain valuable and often very scarce materials like lithium, cobalt, and nickel that can be recycled and reused in new materials. However, traditional methods of battery recycling are often inefficient, expensive, and harmful to the environment. Thankfully, there are innovative technologies emerging that are revolutionizing battery recycling, offering more sustainable and efficient solutions to address the growing problem of battery waste. These new methods are not only environment-friendly but also cost-effective, making them a win-win solution for both businesses and our planet. So, by adopting these new technologies, we can reduce the amount of battery waste that ends up in landfills and minimize the need for new mining operations to extract these valuable materials, which will not only help us protect the environment, but also ensures a more sustainable future for generations to come. Hello and welcome to my channel, The Technical Domain. Guys, if you are new in my channel, then please don't forget to like, share and subscribe. Also press the bell icon to get notified about every contents we create. Keep supporting me so that it helps me create similar contents like this. Today we are going to take a closer look at some of the most promising battery recycling technologies in the 21st centuries, which will help to create a sustainable future to our upcoming generations. Lithium-ion battery recycling. Lithium-ion batteries are widely used in a variety of applications and are known for their high energy density and long battery cycles. However, their recycling presents several challenges, including the complexity of the battery chemistry, the lack of standardized recycling processes, and the potential safety hazards associated with handling the used batteries. Innovative recycling technologies are being developed to overcome these challenges, such as hydrometallurgical processes that use water-based methods to extract valuable materials, and advanced sorting technologies that use robotics and AI for efficient and automated battery disassembly. Companies like Lee Cycle and Redwood Materials are making significant progress in developing these new technologies, which have the potential to greatly improve the sustainability and efficiency of lithium-ion battery recycling, reducing the environmental impact and promoting a circular economy for battery industry. Lead-acid battery recycling. Lead-acid batteries are widely used in automotive and industrial applications, and their recycling has been well established for many years. However, traditional lead-acid battery recycling methods are often associated with environmental concerns, such as lead contamination and high energy consumption. But new and innovative technologies, like aqua refining by Aqua Metals, are revolutionizing lead-acid battery recycling by using closed-loop electrochemical processes that eliminates the need for smelting and reduces carbon emissions, and these new technologies have the potential to make lead-acid battery recycling more sustainable and economically viable, while recovering valuable materials for reuse of new batteries. Nickel-cadmium battery recycling. Nickel-cadmium batteries have been widely used in portable electronics and other applications, but their recycling poses challenges due to the toxicity of cadmium and the complex battery chemistry. However, innovative technologies are being developed to tackle these challenges, such as advanced hydrometallurgical processes that can recover valuable metals from nickel-cadmium batteries, while minimizing environmental impacts. Companies like Umica are making progress in developing these technologies, which have the potential to improve the sustainability and efficiency of nickel-cadmium battery recycling, reducing the environmental risks and promoting resource conservation. Comparison of different battery recycling technologies. For example, some technologies may be more suitable for specific types of batteries, while others may have high recovery rates or lower environmental impacts. The potential for these technologies to work together in a comprehensive battery recycling system, where different types of batteries are processed using appropriate methods, will also be discussed. This will provide an overview of the current landscape of battery recycling technologies and their potential impact on the environment and the battery industry. Future of battery recycling. The future of battery recycling holds significant potential for further advancements and innovations, with emerging technologies like sodium-ion, solid-state and silicon anode batteries, which might disrupt the battery recycling industry by changing the composition and chemistry of batteries and requiring new recycling methods. Additionally, advancements in AI, robotics, and automation could further optimize battery sorting and processing, making recycling more efficient and cost-effective. The economic and environmental impact of these potential advances in battery recycling will be discussed, emphasizing the importance of continuous innovation in this field to address the growing problem of battery waste. In conclusion, battery recycling is a critical component of a sustainable approach to managing battery waste, and innovative technologies are playing a pivotal role in revolutionizing battery recycling. With the increasing demand for batteries and the environmental concerns associated with battery waste, these innovative technologies are offering sustainable, efficient, and economically viable solutions to tackle the growing problem. Technologies such as closed-loop electrochemical processes, advanced sorting technologies, and advanced hydrometallurgical processes are making significant progress in improving the sustainability and efficiency of battery recycling, reducing environmental impacts, and promoting a circular economy for batteries. Furthermore, as the battery industry continues to evolve and new battery chemistry, like solid-state batteries, gain prominence, the future of battery recycling holds promising opportunities for further advancements and innovations. Emerging technologies in AI, robotics, and automation could further optimize battery sorting and processing, and new recycling methods may be developed to address the unique challenges associated with different types of batteries. These advancements have the potential to significantly reduce the environmental impact of battery waste, promote resource conservation, and contribute to a more sustainable approach to managing batteries throughout their life cycle. Continued investment and support for these technologies is crucial for mitigating the environmental impact of battery waste and ensuring a sustainable approach to managing batteries. As the demand for batteries continues to rise, the adoption of innovative battery recycling technologies is essential for promoting a circular economy for batteries and creating a more sustainable future for energy storage. This was all for today. Hope you guys are doing well. If you are new here, then please don't forget to like, share and subscribe my channel. Also, press the bell icon so that you get notified about every contents we create. See you in the next videos. Until then, bye bye and take care.